Introduction. Have you ever wondered if every number can be written as a fraction? Numbers like 1/2 and 3/4 are easy. But what about square root 2 and pi? Their decimal digits never end and never repeat. These mysterious numbers are called irrational numbers. And together with rational numbers, they form real numbers. Today we'll understand everything visually and simply. Recap of rational numbers. Rational numbers can be written in the form PQ. Here, P equals integer. Q equals integer. Q not equal to 0. Examples: 1/2, 3/4, -5/7. Their decimal expansions either terminate or repeat forever. Example: 1/2 equals 0.5. Example: 1/3 equals 0.3333. But mathematicians discovered numbers that do not follow this rule. Introduction to irrational numbers. Irrational numbers cannot be written as fractions. Their decimal expansion never ends and never repeats. Examples: square root 2, pi, square root 5. Decimal expansion of square root 2 equals 1.4142135562. Decimal expansion of pi equals 3.1415926535. No repeating block exists. Digits continue infinitely. Imagine a square. Each side has length 1 unit. Now calculate the diagonal. We use Pythagoras Theorem here. 1 square plus 1 square equals diagonal square. Therefore, 1 square plus 1 square equals d square. Simplifying, 2 equals d square. So the diagonal becomes d equals square root 2. Mathematicians then asked, can square root 2 be written as a fraction? The answer shocked the world. Proof that square root 2 is irrational. Let us assume square root 2 is rational. Therefore, square root 2 equals p by q. Here p and q are integers. Also, p and q have no common factors. Now square both sides, 2 equals p square by q square. Multiply both sides by q square equals 2q square equals p square. This means p square is even. If p square is even, then p is also even. Therefore p2k. Substitute again, 2q square equals 2k square. Simplifying, q square equals 2k square. Now q square is also even. Therefore q is even too. So both p and q are even. That means both are divisible by 2. But earlier we assumed p and q have no common factor. This is a contradiction. Therefore our assumption was wrong. Hence square root 2 is irrational. Real numbers. Rational numbers and irrational numbers together form real numbers. Real numbers include natural numbers, whole numbers, integers, fractions, decimals, irrational numbers. Every point on the number line represents a real number. Representation on number line. Rational numbers can be represented on number lines. Irrational numbers can also be represented. Square root 2 lies between 1 and 2. Pi lies between 3 and 4. Real numbers completely fill the number line. Important difference. Rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. Rational decimals terminate or repeat. Irrational decimals never terminate and never repeat. Quick recap. Irrational numbers cannot be written in PQ form. Square root 2 and pi are irrational numbers. Their decimal expansions never end and never repeat. Rational numbers plus irrational numbers form real numbers. Every real number can be represented on a number line. Mathematics becomes more fascinating as we go deeper into numbers. In the next video we'll explore decimal expansions repeating, patterns and the mystery of cyclic numbers. Subscribe to Academia Visionis for visual learning and concept-based education.